Hello students, in this video lecture we'll continue with conic sections where we'll discuss how to draw parabola by eccentric method. Conic sections, fine. We have already seen how to draw an eccentric way of drawing an ellipse, and we have seen in the previous lecture about a rectangular method of drawing an ellipse, rectangular method. Now we'll see how to draw an parabola by using eccentric method. Parabola by using eccentric method. Okay, now we'll try to recall few of the points related. If you talk about the eccentric method, the eccentric is represented with E. Eccentric is represented with a letter E. If E is equal to 1, then it is nothing but a parabola. If E is greater than 1, then it is hyperbola. E is less than 1, then we call it as an ellipse. And this is we have discussed in the previous session already. Now if you talk about E is equal to 1, now for example in ellipse eccentric method we consider E is equal to 2 by 3, where we consider two parts from vertex, from focus, and 3 parts from the directrix. Okay. So if you take E is equal to 1, we'll consider midpoint. Okay. Midpoint nothing but midpoint, that is in between directrix and the focus point, midpoint. Okay, that we'll see. This we'll see when I draw the actual sketch. This is how we'll do. Now when we considered ellipse by using eccentric method, E is equal to 2 by 3. In the same way, parabola by using eccentric method, E is equal to 1, means nothing but the midpoint. Okay, equal divisions, like 2 parts, maybe 2 parts from the focus, 2 parts from the directrix, if you take this as the formula. Now other than this, before I move on to drawing the actual sketch, let us talk about the application point. Student will have a small doubt in his mind, like what is the application point where we use this particular methods, this concept, complete concept, where we use actually in actual practice. If you talk about the application point of this particular concept, now this is used in laser treatment. Now where we'll try to perform laser treatment when, for example, some stones are formed in a human kidney, then we'll try to perform laser treatments. Now the treatment, complete treatment goes with the concept of this kind. Okay, eccentric concept. Okay, laser treatment can be performed. Other than this, there is one more called in case of electrical reflectors also this concept is applicable. Similarly, for in case of planetary arrangement, and you can elliptical gearings also, elliptical gears. So there are many other. This is how the applications will work out. This is not just we are drawing for our understanding. There is lot more scope in application also. Okay, these are terms. If you could remember, it would be better to answer if you come across any of the Viva questions in and around. Okay, let us start drawing the actual sketch. Now let us consider few parameters. Now let us consider E is equal to 1. The question is given, draw a parabola or construct a parabola, or else he'll give you when E is equal to 1. Eccentricity is equal to 1, nothing but a parabola indirectly. Okay. Followed by focus distance will be given to you. Focus is equal to maybe 50 mm focus, and he may ask you to draw tangent and normal, okay, at a distance of maybe 70 mm from directrix. Okay, this is the question. Let us take this as the given data. Now if this is the given data, what the basic thing that we do is, we'll try to draw a vertical. Okay, I'll name it as AB, which we call it as directrix. Then at some point I'll try to draw horizontal. Let us name it as CD. Now this AB, CD are not standards. You can give any notation. Now let us mark, now we call this CD as axis line. Now let us mark focus distance of 50 mm. Focus distance of 50 from the directrix point. Let us consider this as that particular point, F, focus. Okay. Now as I said, 2 parts or 3 parts, equal divisions we need to make from the focus and from the directrix. So from here I'll try to find the midpoint. Let us consider this distance as 50, which is given in the question. Now let us consider the midpoint of it, which is at 25 mm. Now this is vertex, where parabola will start its curve. Okay, the curve will start at this particular point. Focus is always constant. Now I'll consider this distance VF. I'll consider VF as the distance. Then here I'll try to draw a small simple vertical of infinite distance. I'll measure VF distance and make a mark on this particular line. The way we have constructed ellipse by eccentric method. Similar fashion, I'll consider VF as a distance, V as center. What is that? VF as radius, V as center. Then I'll make a mark. Let us consider this point as E. Now draw a straight line passing through CE up to some infinite distance. Now place your drafter aligning these 2 points and draw a straight line of this kind up to some infinite distance. Okay. In a similar fashion you can do to the other side also. Okay. In case of parabola, hyperbola, ellipse, if you consider eccentric method, you can consider both the sides, not a problem. Okay, so same distance you can make a mark here. You can take the inclination to the downside also, okay, to draw the sketch properly, neatly. Okay. I do the same to the other side. I can extend this line. I'll measure this distance, same distance, V as center. I'll just make a mark. Then draw a straight line passing through C prime. Let us consider this point as E prime. Okay, this is the construction, simple construction. Now I'll try to divide the axis line from V into number of segments. Okay. There is no predefined segment. Like for example, it is not compulsory that you need to make it 10 divisions or 8 divisions or 5 divisions. Okay, and also it is not compulsory that you have to maintain equidistance. Okay. If you maintain equidistance, it is always better, but it is not compulsion. Okay, from V I'll start making divisions with an offset distance of 10 mm. From here I'll make a mark. Okay, maybe 10, 20, 30, 40, 50, 60. I'll try to give numbering. Let us consider this as 1, 2, 3, 4, 5 and 6. Now wherever I have marked, I'll try to draw an extension line. From here I'll draw an extension until it meets the inclination above and below. Similarly to the second one, above and below. Similarly to the third one. Now this is a similar fashion, similar construction we have followed in case of ellipse also, eccentric method of ellipse, that we have seen in the previous lectures. Okay, with 2H pencil. Everything has to be constructed. Complete construction has to be made with 2H pencil only. Okay, whether it is Directrix, axis line, notations, dimensions or complete construction. If this is 1, I'll consider this as 1 prime, 2 prime, 3 prime, 4 prime, 5 prime and 6 prime. Now focus will remain same. This focus point where I have made a mark, I'll try to make a mark again, 4 at this particular point. Focus will remain same. Focus acts as center now. Center is equal to, center is focus acts as center and radius will keep on change the way we did in ellipse method also. Like radius will be like 1 prime is first radius, 2 prime second radius, 3 prime third radius up to the last one, n prime. Now what I do is I'll try to measure 1 prime distance, focus as center. I'll just make a mark above and below of same line, 1 prime. Okay, F as center, 1 prime as radius. I'll try to cut here, maybe 1 above, 1 below. Okay. Second, 2 prime as radius, focus remains same. I'll make a mark here, 1, 2, 3 prime, F as center, 4 prime, again F as center. Obviously it will cut the, tangentially it will cut the point. 5 prime, F as center, 6 prime. If you try to divide this into number of segments also, maybe further 7, 8, 9. If you keep on increase the number of divisions also, the curve not going to come down. This intersections above and below will not come down. It will keep on going in incremental way, because here we have taken the midpoint of directrix and focus. Okay. If that is the case, then this will not change. Okay, sorry, the focus point 3 is the focus point. No, here 3 is the focus point of this one. This is the focus point because 50 distance we have already considered. Now whatever the markings we made, try to give naming to that particular markings, like maybe P1, P2, P3. Likewise try to give intersection naming. Then whatever the curve you got, try to join with freehand from the vertex. This is the curve initially with 2H pencil. Okay. Once that is done with your free hand, try to darken with HB pencil. Okay, if you keep on divide if you make more number of divisions also, this curve will start moving. I mean, it will move this way only. This is how we'll construct a parabola. Only everything has to be drawn with 2H pencil, only curve has to be represented with this particular HB pencil. Now give notations. If this is P1, this intersection becomes P1 prime. Similarly P2 prime, P3 prime, P4 prime. Okay. Now other than this, the question is again 70 mm. Is asking to draw tangent and normal at a distance of 70 mm. So to mark that, already we have marked this 50 already marked. So from there 20 more mm somewhere here. From the Directrix, if I measure with the help of a scale, it is going to cut the curve somewhere here, maybe 20, 30 at this particular point, maybe at this point. Let us consider that point as maybe P. Join this point with a focus. Join this point the similar fashion the way we implemented for ellipse by this particular eccentric method. Try to join this with the focus, okay, with 2H pencil. Now draw a line perpendicular to this particular line, perpendicular to this. Align your one of your scale of drafter to this particular line, then draw a straight line which will maintain 90 degrees from here, okay, 90 degrees until it meet the Directrix, not to the other side, until it meet the, so the line may be of this kind. If I draw a straight line with 2H pencil, it will go and meet the Directrix somewhere. Let us consider this point as, and from here draw a straight line passing through TP, which we have already represented, shown. Now from TP draw a line, it will pass something like this. Now this TP, if you try to darken this line, this will look something like this. TS, I'll name it as TS, which is, TS is always represented as tangent, and to this line I'll try to draw one perpendicular, maybe of this kind, which is MN. Always will represent MN as a normal. This is how we will construct tangent and normal. I'll repeat. Now here we have marked the point for tangent and normal, which is already given in the question, 70. Now I'll consider that point as P. I have joined that point with the focus. From focus I have drawn one more line perpendicular to this line PF. Okay. Now wherever it meets the Directrix, I'll consider that as T. From there again I'll draw one more straight line passing through TP. Okay, it's up to some infinite distance. Now this TX acts as tangent, and perpendicular to that MN is nothing but your normal. This is how we'll construct parabola by using eccentric method. Now in brief, I'll try to draw all the three in this way. For example, this is the Directrix axis line. If you consider it as V, somewhere here, this point as V, then the ellipse is going to be something like that. This is the ellipse, followed by, there will be a parabola. This is how parabola will look like. Then again a hyperbola will look something like this. The first curve, this is the first curve. This first curve we call it as ellipse, okay, which will turn 360 degrees. There will be a meeting point. And this one parabola, this one hyperbola. Okay, this is how we'll do. When in case of ellipse is less than 1, parabola E is equal to 1, hyperbola E greater than 1. This is how we'll do. This is our for now. If you have anything to ask, any queries if you have, please comment in the box given below. Thank you for now.